Okay, so now we're going to talk about yields as it relates to chemical reaction. And as you can see on the screen, let me go to full screen here. Okay, so the first definition here, and again, this is something you should have met before in your introductory or high school chemistry. Theoretical yield. What does this term mean? Well, basically, this is the amount of product you expect to get based on stoichiometric calculations. So all the examples that we may have looked at before where we calculate the amount of product based on the given amounts of reactants, of course, also based on the balanced equation and subsequent calculations, the amount of product that is calculated based on that will be the theoretical yield, all right? Now, in practice, what you'll find is that the amount of product that you actually get will be less than what is calculated, all right? What is calculated is basically what would happen if everything worked out perfectly. In an ideal world, you'll get basically what you calculated on paper. But in practice, when you actually carry out an experiment to produce a particular product, then basically what you'll find in the vast majority of cases is that the amount of product is less than the actual yield, than the theoretical yield, I'm sorry. So therefore we call this the actual yield. All right, so there's a difference between the actual yield and the theoretical yield. The theoretical yield is the amount of product that you expect to get based on your calculations, while the actual yield is the amount of product that you get when you did the experiment and isolate the product in practice. And what you'll find is that the actual yield is almost always less than the theoretical yield. So the ratio between these two is called the percent yield, where you divide the actual yield by the theoretical yield times 100%. And this is used as a measure of how successful the reaction is in terms of the amount of product you get. And in practice, usually percent yields are pretty low. Now, if you get somewhere in the order of 80% yield, for example, you're doing pretty good, all right, in terms of the amount of product you get versus what you expect to get. But typically, especially when it comes to organic reactions, what you'll find is that the amount of product is maybe about in the 50s and below, all right? Now, here's a question that is being asked. It says here that the actual yield will be less than the theoretical yield for many reasons. Can you name some? All right, and there are a couple of reasons why the actual yield is less than the theoretical yield. One reason is, in fact, maybe I should make some notes here while I'm speaking. So let me insert a new slide. And let me just make some notes here. Okay, so what I'm going to outline are a couple of reasons why the actual yield for a reaction is less than the theoretical yield in the vast majority of cases. So let me get my ink, black ink here. Okay, so one reason is that some reactions are reversible. In fact, most reactions are reversible. Some reactions are reversible, all right? So this is my reason number one why the actual yield is less than the theoretical yield. All right? Okay, so the first reason is that some reactions are reversible. And as you can imagine, if you think about it, this would affect the amount of product you expect to get, because basically, if you have a reaction going from A to B, right? But you also have the possibility of B itself reacting to form A, right? Then basically the amount of B that you expect to get, which is the product, would be reduced by the fact that B itself will react to form A, all right? So that's one reason why the actual yield is less than the theoretical reason. Another reason why the actual yield is less than the theoretical yield is that there can exist what we call competing reactions. Now, what do we mean by that? Well, basically, you can have the possibility of A forming B, but you can also have the fact that A can also form another product, C. I'm sorry. So therefore, you have these two possible products being formed. So therefore, not all of A will be used to form B. Some of A will react to form C, right? And therefore, that would affect the amount of product B you expect to get, all right? And as a result, the actual yield will be less than the theoretical yield, all right? Third reason is that you can have the product itself reacting to form other products. All right, so for example, using the same hypothetical AB that we have been using, you can have A reacting to form B, and then B itself reacts to form some other product C, right? So therefore, again, as you can see, as you can imagine, it's kind of obvious that the fact that B itself will react to form C, that will reduce the amount of B that will be present or that will be formed, and therefore, as a result, the actual yield will be less. And then we also have the other possibility of basically errors made by experimental, right? You know, I mean, little things that could happen, like, for example, incorrectly weighing stuff, either reactant or product, spillage along the way, etc. So, you know, basically human error can be a factor as well. All right. So these are some of the reasons I can think of right now off the top of my head as to the reasons why the actual yield would be less than the theoretical yield. All right. So in this example here, we're looking at the formation of zinc sulfide as a result of the reaction with zinc and sulfur, right? So basically they mix the zinc and the sulfur in this dish and light it. Of course, it's an exothermic reaction. We're going to learn about that later on, the difference between exothermic reaction and endothermic reaction. But basically in an exothermic reactions, it generates a lot of heat and light. And then after everything settles, you look at what you end up with. And what you'll find is that not only will you have the product zinc sulfide, right, which is what you're trying to make, but you also have some other products or other substances remaining. You'll have, for example, zinc oxide, which is formed as a result of the zinc reacting with the oxygen from the atmosphere. So basically, we have a competing reaction, right? Apart from the reaction that produces the zinc sulfide, you have a competing reaction which produces zinc oxide, all right? In some cases, I didn't mention this in the previous slide, but in some cases, the reaction may not result in all of the reactant forming. So you may have some unreacted zinc, all right? And also you may have impurities that were present in the original reactants, zinc and sulfur. So these are some other factors that could affect the actual yield of zinc sulfide being less than the theoretical yield, all right? Okay, so what I want to do next is to look at an example, a typical problem involving percent yield, right? So what I'm going to do is stop this video here, and then the next video is where we'll focus on this worksheet that I pulled up from Google. Okay, so that's basically it for this video. Until next time.